It's that time of year again. No matter how much bug spray you use or how many citronella candles you light, you still end up getting eaten alive by mosquitoes. Mosquitoes eat you, then dragonflies eat mosquitoes. In fact, sometimes dragonflies are nicknamed mosquito hawks because they are so good at finding and eating mosquitoes. But if dragonflies are so good at eating mosquitoes, why is it that there are so many more mosquitoes than dragonflies? To answer this question, we need to learn a little bit more about how a food chain works. In order to get the energy needed to fly around, find shelter, and mate, mosquitoes need to eat food. It's actually only the female mosquitoes that drink your blood. The male mosquitoes eat nectar from plants. But in order to make their eggs, female mosquitoes need the nutrients they get from drinking other animals' blood. This puts you at the bottom of the mosquito food chain. When a mosquito drinks your blood or eats nectar, the mosquito gets food made of biomolecules. But despite taking in lots of biomolecules when it eats, the mosquito isn't gaining a lot of weight. Only about 10% of the biomolecules are used for growth. The rest of the biomolecules are used for energy, which the mosquito gets by doing cellular respiration. During cellular respiration, the mosquito uses up the biomolecules, breaking them down into carbon dioxide and water that it breathes out. But when the biomolecules are broken down, energy is released that the mosquito can use to fly around, looking for more food, shelter, or mates. Every day, the mosquito needs to eat more food so that it can get more energy to live its life, because most of the matter that it eats ends up being breathed out. But one day, snap! The mosquito gets eaten by a dragonfly. Just like how the mosquito needs to eat a lot of food in order to have enough energy to live its life, the dragonfly needs to eat lots of mosquitoes in order to have enough energy too. When the dragonfly eats mosquitoes, any biomolecules that made up the mosquito's cells can be used by the dragonfly. And just like how most of the biomolecules the mosquito eats are used for cellular respiration, most of the biomolecules that the dragonfly eats are also used for cellular respiration. Flying takes a whole lot of energy. But that's not where the food chain ends. One day, our dragonfly might get eaten by a bird, and any biomolecules that made up the dragonfly's body can be used by the bird. So now we have our food chain. At the bottom, we have you, or me, and we are eaten by mosquitoes. Our biomolecules are used by the mosquito, which is then eaten by the dragonfly. The dragonfly uses the mosquito's biomolecules, but the dragonfly is eaten by a bird, and any biomolecules that were in the dragonfly have now been transferred to the bird. So let's go back to our original question. Why are there so many more mosquitoes than dragonflies? When the mosquito eats, only about 10% of the biomolecules that it eats are stored in its body. The rest of the biomolecules are used for cellular respiration. The energy in the bonds of the biomolecules keeps the mosquito alive, while the atoms are breathed out as molecules of carbon dioxide and water. This means that only 10% of the biomolecules that were eaten by a mosquito are actually able to be consumed by the dragonfly. So let's say that the mosquito eats 10 milligrams of food in its lifetime. Of that 10 milligrams of food, only 10%, or 1 milligram, would go into the dragonfly. But this works for the dragonfly too. Of that 1 milligram that went into the dragonfly, only 10% of it can be used to build more dragonfly cells. The rest is used for cellular respiration and breathed out. This means that only 0.1 milligrams of the original 10 milligrams is actually available to the bird that eats the dragonfly. 0.1 milligrams. If you could cut a grain of salt into 250 pieces, each piece would weigh about 0.1 milligrams. That's not nearly enough food for a bird. So the bird has to eat a lot of dragonflies, and the dragonflies have to eat a lot of mosquitoes, and the mosquitoes have to eat a lot of you just to stay alive. This rule that only 10% of the biomolecules from one organism are used for growth and therefore passed on to the next level in the food chain is called the 10% rule. Technically, we talk about the 10% rule in terms of energy, but because energy is stored in high-energy bonds in biomolecules, we can think about energy and biomolecules interchangeably. And the 10% rule explains why there have to be so many more mosquitoes than dragonflies. If only 10% of the energy, or biomolecules, are passed on to the next level of the food chain, then the bottom of the food chain has to be much larger than the top of the food chain. If there were more dragonflies than mosquitoes, then dragonflies would run out of food. The 10% rule also explains why food chains are only made of 4 or 5 organisms. Let's look at this other food chain. Here we have plankton, which are eaten by krill. Krill are eaten by silverfish. Silverfish are eaten by seals, and seals are eaten by orcas. The orca's biomass is about 8 calories per square meter per year. Using the 10% rule, we know this means that seals must have a biomass of 80 calories per square meter per year, because 10% of 80 is 8. But that means there must be 800 calories per square meter of silverfish per year, and 8,000 calories of krill, and 80,000 calories of plankton per square meter per year. That is a whole lot of plankton. Now let's review. The 10% rule says that only 10% of the energy from one level in the food chain is passed to the next level. Because energy is stored in biomolecules, also known as biomass, the amount of biomass at the bottom of the food chain has to be much greater than the amount of biomass at the top of the food chain. Each time an organism eats, most of the biomass in that food is used for cellular respiration. Only about 10% is used for growth, and that part is able to move to the next level of the food chain.